Hi, welcome back to your friendly neighborhood Algebra 2 teacher. Today's lesson is 5.4, Solving Exponential Equations Using Logarithms. So if you remember back when we were looking at common bases back in Unit 4, we were noticing that the only way that we could possibly solve an equation that had an x in it, like 2 to the x is equal to 8, in case you could put that 8 into the same base as 2. So we rewrote this as 2 to the x equals 2 to the third, therefore x must equal 3. But what we're concerned about now is what happens when we can't put things into a common base. So we need to use logarithms to solve for those exponent variables. And we're going to use that third exponent law, which is the power law, where we throw that exponent out front. And you'll see how easy it makes it. I mean, it's hard to believe that you've been through all this math and you've never learned how to do logarithms. And like I said, it's a crazy name. Like you hear logarithms and the hair on the back of your neck stands up, but it really isn't so bad. And I'm hoping you're starting to feel a little bit more comfortable with them. So let's look at exercise number 1. Solve 4 to the x equals 8 using common bases and then the logarithm law shown above. So common bases, now beware, 4 to the x equals 8. It's not 2 because 4 squared is 16. So it's a really common misconception to just, run in there and say, oh, well, you say 4 to the x. So 4 to the x is equal to 8. Common bases bring it down to base 2. So I know 4 can be written as 2 squared to the x is equal to 2 to the third power. So this becomes, so now at this point now we just multiply these two and I get 2x is equal to 3, divide both sides by 2 and x equals 3 over 2. Now using the logarithmic approach, we're going to start with the same problem. We're going to say 4 to the x is equal to 8, and we're going to log both sides. Now, common logarithm is basically what we use, but you can really log in any base. But we're going to use common logarithm, so we're going to log both sides. So what I mean by that is we're going to log 4 to the x is equal to log of 8. And remember, you can do anything to either side of the equal sign and maintain the equality. So now go back to what we know about 4 to the x. We can throw that x out front and make it x log 4 is equal to the log of 8, log 8. And then to solve for x, we simply divide both sides by log 4. So these cancel, and x is equal to log 8 divided by log 4, which you're going to put right into your calculator, and obviously the answer is going to come out to be 3 over 2 or maybe just 1.5. Depends on which way you want to represent your answer. All right, so the beauty of this logarithm law is that it removes the variable from the exponent. This law in combination with the logarithm base 10, the common log, allows us to solve almost any exponential equation using calculator technology. All right, so finish writing that up and let's get on to exercise 2. All right, so solve each of the following equations for the value of x. Round your answers to the nearest hundredth. Okay, round. So we're going to do this exactly the same way we did on the top in exercise 1. So we're going to log both sides. So log 5 to the x is equal to log 18. So x log 5 is equal to log 18. Divide both sides by log 5. Notice how I don't put in my calculator log 18, log 5, because you get these crazy big numbers. So much easier just to do it at the end. So x turns out to be 1.7958. But it says rounded to the nearest hundredth, which means that we're going to cut it here. Now beware, we're going to move around to the other side. If it says to the nearest hundredth, it means you need to have 2 spaces next to the decimal point, 2 digits. So don't write down 1.8 here. This is 1.80. Okay, because we have to kick that We look here, this is 5 or greater, so we have to kick that 9 up by 1, so that 79 becomes an 80. Why don't you try and set the next two up and see what you get? You don't have to worry about it. If you can't get the logarithm part, I'll help you out with that. Just set it up. So hopefully what you got is you log both sides. You got log 4 to the x is equal to log 100. So you get x log 4 is equal to log 100. Now log 100 is 2, but we don't have to worry about that right now. Divide both sides by log 4, and x turns out to be 3.329. Rounding to the nearest hundredth, x is equal to 3.32. Now, hopefully, you're going to get to the point where you're going to start skipping that step because you're going to know when you log this, it's going to become x log 2 is equal to log 1560. And then you're going to divide both sides by log 2. If you can't skip this step, please don't, okay? It will become a little bit easier for you. So x turns out to be here 10.6073. So answer turns out to be 10.61. All right, so those are the simplest of the logarithmic equations. Of course, they're going to get a little bit harder, but I feel like if you know the premise here and you understand how you pull that x down using that power law, the rest of it is kind of, it follows suits and it gets easier. All right, so let's look at exercise 3. So we have x plus 3 as our exponent here. So we're going to follow the same rule we just did. We're going to, let's not skip the step yet. So let's just log both sides. So now we just pull that x plus 3 out front like we did before. But x, I'm going to put in parentheses just to protect it. So I realize that it's not attached to the log. So x plus 3 log 6 is equal to log 50. And we're going to do the same thing. Before I can touch that x, I need to eliminate that log 6, or at least move it over. So I get x plus 3 now is equal to this mess, log 50 over log 6, and then simply subtract 3 from both sides. And I'm going to put that whole thing into my calculator. And x turns out to be negative 0.82. Looks like I already rounded it. So we'll practice putting these larger expressions into our calculator, all right, to get a value. So in B, I'm going to kind of skip the step again because I feel comfortable, like I think you're feeling comfortable enough. So I'm going to say x over 2 minus 5, again, I'm going to put in parentheses, times log 1.03 is equal to log 2. I'm going to divide out the log 1.03. And I get x over 2 minus 5 is equal to log 2 over log 1.03. Again, if you want to put that in your calculator, just don't round it too soon. And then we're simply going to add 5 to both sides. We're going to add 5 here, so these cancel. So we get x over 2 is equal to log 2 over log 1.03 plus 5. This might be a good time to put this in my calculator because what we're going to do next is multiply both sides by 2. Multiply both sides by 2. So if you're confident with your calculator and you can put that whole expression in, then you're golden. All right, if you have some trouble with it, then do it in pieces. But the answer here turns out to be 56.8995, which they tell us to the nearest hundredth again. So x is 56 point, again, 90. All right, so now that we have spent some time solving equations, now we have to take a look at some modeling problems. Because I'm going to remind you that nobody's ever going to hire you to just solve equations. Mathematics is a tool that we use in physics, in science, in real life situations that we can use in order to solve the problems. So, finish writing that up and meet me over at exercise 4. So we're going to go back to our definition of an exponential function. In this case, we say q of t is equal to q naught. Now this little zero here, we say q naught, which always represents, sorry about that, always represents the initial value of 1 plus p, and in rates, that would basically be your rate, all right, raised to the time. So this is nothing different than what we did earlier in the year. So exercise 4. A biologist is modeling the population of bats on a tropical island. When he first starts observing them, there are 104 bats. So, bam, there's my initial. The biologist believes that the bat population is growing at a rate of 3% per year. So already I know that we're talking about exponential because they're talking about an initial, they're talking about rate, and they're talking about time. So when you have those three things, exponential functions come into play. All right. Also, when they're talking about things like populations, all right, populations and money are two things that grow exponentially. All right, so A says write the equation for the number of bats, they're going to call it B of t, as a function of the number of years t since the biologist started observing them. So we're going to use our knowledge of writing exponential equations to say B of t is equal to my initial. I know they're growing, so my 3% is 0.03. So 1 plus 0.03 raised to the t power. Now, using your equation from part A, algebraically determine the number of years it will take for the bat population to reach 200. So recognize where that 200 is going to go. They're asking us to solve for time. So they want us to solve for that t. So what we're going to do is that 200 becomes what my new population is equal to 104 times 1.03 raised to the t power. And now we're going to solve that. And you know me, when I'm solving for t, I like it on the left side. So I'm going to flip-flop these. Doesn't matter how you do it. If you're comfortable working on the right, please feel free to do that. So if we're solving for t, the first thing we have to do, before we even log it, I'm going to divide out the 104. So I get 1.03t is equal to 200 over 104. Now, you know something? Let's make it a little bit easier. Let's reduce this to 25 over 13. Only because it's nicer to work with smaller numbers. You can very easily leave it as 200 over 104 because when we log both sides, you're going to come up with the same answer either way. Oh, I just realized I put the t in the wrong spot. Should be here. So now we log both sides. So this becomes t log 1.03 is equal to log 25 over 13. We're going to divide both sides by log 1.03. These cancel. But when you put this whole thing into your calculator, t turns out to be 22.1229. And it says round your answer to the nearest year. So it's going to be 22 years. Whenever I get a decimal, I always go back up and watch to see or look to see how it tells me to round it. All right, leave it there for another second so you can write it down. All right, exercise 5, last one. A stock has been declining in price at a steady pace of 5% per week. So the first thing I do is 0.05. If the stock started at a price of $22.50 per share, determine algebraically the number of weeks it will take for the price to reach $10. And then it says round your answer to the nearest week. All right, so we're talking about initial. So they don't tell us what to call anything, so it doesn't really matter. So let's just say y equals 2250. It's declining 1 minus 0.05 raised to the time. All right, so it's telling us $10. So $10 is equal to 2250, 1 minus 0.05. You know, let's rewrite that as 0.95. Hello. 0.95 raised to the t. I'm going to solve for t. So again, you know me, 2250, 0.95 raised to the t equals 10. Divide both sides by 2250. 0.95 to the t is equal to 10 over 2250, and log both sides. Just bring this up a little bit so you can see it. So we get t log 95, log 0.95, is equal to log 10 over 2250. Divide both sides by log 0.95. And t turns out to be, now when you're putting this in your calculator, the first thing you do is you open your fraction bar. Open your fraction bar, log, parentheses, open your fraction bar again to put the 10 over 22 over 50. All right, so make sure that when you're done with your calculator, it looks exactly like this. All right. I know sometimes we leave things open and closed and parentheses don't fall where we need it to fall, so just beware of that. This turns out to be 15.806996. All right, so rounded to the nearest week is going to be 16 weeks. So hopefully you'll see that solving these aren't so bad. And it's really just applying that third logarithm law of throwing that exponent out front. All right, so hopefully we're going to be coming into class, spending some time on this. Using your calculator is really key here and being able to, be able to put these large division problems into it properly is a skill that you're going to have to develop. All right, so kept it under 20 minutes, which I'm always happy about. So until next time, please, and when I say this, I truly mean it, make good choices. Think about what you're doing, because we all have consequences based on our choices if they're not good ones. So don't take that lightly. Truly, I mean it. Make good choices. See you next time.